Who's got me? What times what gives me 169? It's got to be the same number.
13 times 13.
13 times 13. Absolutely. So if I think about area as like a square box, wow, should make an actual square. There we go. And 169 is the area. I'm trying to figure out what is the side length. The square root is the side length, right? In that area, 13 times 13 gives me 169. The side length that I'm looking for is 13. So the square root of 169 is 13. All right. A fun fact about the square root of a fraction, it just means the square root of the top over the square root of the bottom. Right? So I can quickly say, what's the square root of 4? It would be 2. What's the square root of 9? It'd be 3. 3 times 3 is 9. 2 times 2 is 4. So the square root of 4/9 is 2/3. I'm taking the square of the numerator, square of the denominator. All right. The square root of negative 36. I'm thinking of one number that I can square in order to get to negative 36. You might think like, okay, what about 6? You're like, nah, that makes positive 36. What about negative 6? That also makes positive 36. There is no real integer that is going to be able to be squared to get negative 36. This is called no real solution. So if we have the square root of a negative, it's not going to work out because we can't square it to get a negative. All right. And then this is just a reminder that the square root and the square are opposites of each other. If we have a square root and a square, we can cancel them, and the answer is just what's left over. If you think about this more concretely, you would have like, if you had the square root of 3 squared, you could say, okay, that's the square root of 9, and the square root of 9 is 3. Or alternatively, you could say the square root and the square cancel, and the answer is 3. Just 2 ways of thinking about the same problem. Looking at those 4 questions, looking at these 4 questions, and then looking at this next question, how comfy do you feel with this? Like, how much do you remember about square roots? Like, do you feel like you need a lot of support? Like, this has always been hard for you, or you don't remember any of it, or you're like, nah, miss, I already got this. I know how to simplify, no problem. This will just inform how fast I move through these problems. Cool. Thank you all for voting here. Thank you, Antoine, for sending that in the chat. Putting that in the poll. Go to about 10 more seconds. Okay, go ahead and try this problem on your paper, right? So you're using what we were just thinking about with the example that was already done for you. What can you break 124 down into? Thank you for your vote. Just so you're aware, we had some 2s, 3s, 4s, and 5s. Feel free if you to either raise your hand or let me know if you feel comfy doing this problem out loud. I'd love to have someone take this away. All right, Antoine, take it away.
I did 4 times 31.
4
That's
times 31.
four.
Wait, Antoine, can I ask you something? Did you just know that it was 4 times 31, or did
I
you?
did it on my calculator until I found that number.
Got it, got it. So what was your calculator process?
It was like going through numbers. So I basically went off like I know 12 and it's 24, and I like broke it up in my head. And then what I did is I know 4 times 25 is 100. So I kept on going from there because I knew if I used six, that would be too big. It would never come to 24. And
Got
I
it.
knew four would automatically go there.
Wow, I love that idea of breaking it into 124. Yeah, absolutely. I love that. Another way, right, is if you had a calculator, just dividing by numbers until you see which one works. But yours is much more elegant. Okay, so you got 4 and 31. Sorry, Antoine. What do you got next?
Oh, that's the furthest I got so far.
Oh, first so far. Okay, great. So we have 4 and 31. Can we break up 4?
Yes,
Yep. Into what?
2 times 2.
2 times 2. And since I broke down this 4, sometimes it gets hard to tell like what in our scratch paper, like what have I broken down and what haven't I? And so I like to just scratch out that number once I have it written down. 31, not divisible by 2, not by 3, not by 4. Since it's not divisible by 2, we can't divide by any even numbers. So 7, no. 9, no. 11, no. 13, no. 15, no. 17, no. Okay, so I know that it is not divisible by those numbers, so it is a prime number. So I've reached prime numbers at each of these. What is the index here? What is the index? It's that little baby number. If there's nothing there, what is it? Does anyone remember from our pattern? 2, yeah, actually, it's 2. So we need groups of 2 of a kind, right? 2 of a kind. It doesn't have to be 2s. In this case, it is 2s. 2 of a kind. So we have 2 2s. That's going to make a group on the outside. And then left on the inside, we have our leftovers. Our leftover is 31. This is the simplified version of this value here, right? If I was to type square root of 124 in my calculator, I would get the same answer as if I was 2 times square root of 31 in my calculator. Both of those are there for sure. All right. Let's take a look at one with variables in it. One with variables in it. We have the square root of 24, x to the third, y to the fifth, z to the ninth. So again, as Ashley told me earlier, I have the square there. It's not it is a square root. It's not an exponent, right? It's the index is telling me groups of how many. What can I break 24 into? I have many options.
6 times 4.
6 times 4, cool. It doesn't matter. You could do 3 times 8. You could do 2 times 12. You could do, those are your options. You could do any of those options. They'll all break down into the same thing because we're going to keep breaking them down. 6 is 3 and 2. 4 is 2 and 2. Crossing out these because I already have them. I'm looking for groups of 2 of a kind. So 2 of a kind, I have a group here. That's going to make a 2. Then inside, I'm leaving some space here because I know I'm going to have variables. Leaving some space, so I have the 3 and the 2 are going to be left over. 3 times 2 would be 6. So the 6 is staying inside. So 2 on the outside, 6 on the inside. I have a bunch of variables here. I could write them all out, like x times x times x, and then I could say like, okay, a group of x's is coming to the outside, and 1x is left on the inside. And then I have y times y times y times y times y, and then I have a group of y's, another group of y's. So I have y squared on the outside, and 1y left on the inside. Is there a faster way? I don't really want to write all of these out. Is there a faster way?
Can't you wait? I know this might sound crazy. I
Try
don't
it.
know. I was thinking like, okay, so it's three X's already, and then it's five. So you would take the two because it needs to be groups of two. So you would take two from the X, and then you would take technically two groups from the five, which would be two groups of Y's, and then it will be the two leftovers, and you could just multiply them together. I don't know. That's just something I thought of in my head.
Yeah, I like that idea. So there was one group in here, so that group came to the outside, but that one was left over, and then you made the two groups of the Y's, but there's one Y left over. So those X and Y is being multiplied in the end here, right? Being multiplied in the end here. I like that idea. What can I do with the Z's? I heard some of this start to happen. What can I do with the Z's? Do I need to like write them out every time so that I can circle how many groups I have? Is there a way I could do in my head, like if I have 9 Z's, how many groups of Z's do I have? I have 1, 2, 3, 4 groups of Z's because I'm making groups of 2, right? So I have 2 Z's here, 2 Z's here, 2 Z's here, 2 Z's here. So that's going to make Z to the 4th power 4 groups on the outside, and there's 1 Z left over. 1 Z left over on the inside of the square root. I could have done this by asking myself, okay, what is 9 divided by 2, groups of 2, right? Oh, it's full, like I can make 4 whole groups, right? That's 8, but then I would have 1 left over. So my 4 Z's go on the outside, my 1 Z goes on the inside. So I can use that division in order to help me, right? I'm asking myself, how many groups of 2 can I make out of 3? I can make 1 group and I'd have 1 left over. How many groups of 2 can I make out of 5? I would have 2 groups of 2 and 1 left over. And that's going to inform me on how to write my square root. How to write my square root. This entire thing is my answer. This is the simplified version, believe it or not, of that there. So 2x y squared b to the 4th square root 6y or xy. Given these examples, talk to me. How are we feeling? How are we feeling? Lesson. Thank you for your votes. Sweet. This is where we're sitting so far. Lots of fours. Okay, we're going to talk through some vocab really fast. Do not feel like you need to write down like all these little bubbles and the arrows. No, just write down what you think is most appropriate for you. So for vocabulary, we already spoke to this little number here, right? The number inside the arm of the radical is called the index. That is our number there. The square root sign, it's not always a square root. Sometimes it's a cube root, sometimes it is a 4th root. So that sign is called the radical sign. That's the radical sign. And then anything that is inside is called the radicand. The radicand. Right? That thing is the radicand. Awesome. We spoke to this a little bit earlier, but if there's no index, right, if there's not a number written there, right, just like on these problems, the index is assumed that the index equals 2. Right, so if there's no index, Whoops, a little laggy today. If there's no index, it's assumed that the index is 2. So for square roots, when they look like this, we're looking for groups of 2. For cube roots, we're looking for groups of 3. For fourth roots, we're looking for groups of 4, like that. So we've already worked with square roots a little bit. Let's jump into some cube root and fourth root examples. I can break down 243. So my 2 is my coefficient. It's just like chilling out there. It's going to multiply. It's going to come basically straight down to the outside. And we're going to see what else is going to be multiplied with it. So 243 is 3 and 81. I can do that by just using my calculator for division. 81 I know is 9 and 9. 9 is 3 and 3. 3 and 3. So in the previous example, I would have circled these 3s and circled those 3s. However, I need groups of 3. This index of 3 is telling me that I need 3 of a kind, right? I need 3 of a kind. So I'm going to circle this one and these 2 together. That's going to go to the outside to make a 3. And then I have a 3 and another 3 left over on the inside. So on the inside of my cube root, I have 3 times 3. Be careful, the cube root, the index 3 needs to stay on that radical sign. Otherwise, it turns into a square root. We don't want that. So I have my coefficient from before, my group coming to the outside, my leftovers on the inside. And I'm going to go ahead and put those together. 2 times 3 is 6. Cube root, 3 times 3 is 9. So 6 cube root of 9 is the same as 2 cube root of 243. These are equivalent to each other. Take a moment to finish writing that example. If you're ready, you can get started on number 8. This is a fourth root. Fourth root. What can we break 160 into? There's lots of options. What's one of those options? Kimberly's got me with 16 and 10. Love it. 16 and 10. You could have also done 4 and 40. Love that too. Either way, you should get the same thing. So we have 16 is 4 and 4, which is 2 and 2. 2 and 2 again. 10 is 2 and 5. All right, we're looking for this time groups of 4. Groups of 4, or 4 of a kind, I should probably say. 4 of a kind. So I have 4 2s, and then left over a 2 and a 5. All right, so 4 2s coming to the outside. Fourth root of 2 and 5 left on the inside. So simplify this, I'd have 2. Fourth root, 2 times 5 is 10. Let's go ahead and try this one here. kind of interesting. I know earlier we spoke to the square root, right? The square root is like we're not able to have a negative square root. However, we can have a negative cube root. And the reason why is because 64 is 4 to the power of 3. If we had negative 4 to the power of 3, we'd have negative 4 times negative 4 times negative 4. It's going to equal 64, but that 64 is going to be negative because we have a negative times a negative times a negative, right? So 64, negative 64 is negative 4 to the third power. So what I can say here is I can actually, I can break this down normally like 8 and 8, 2 and 4, 2 and 2, 2 and 4, 2 and 2, 4 are gone, the 8 are gone. So I have a group of 3s here, a group of 3 here, 3 of a kind in 2 places. So I have a 2 on the outside, and I have another 2 on the outside. All right, that's going to be that 4. If you feel comfortable, cube root of 64, you could just jump to say, okay, the cube root of 64 is 4. Right? That's your outside. You know that you have nothing left over. Right? The negative is going to come down here as well, because when we have a cube root, an odd index, like 3 or 5 or 7, the negative is able to be removed, because a negative times a negative times a negative is going to be a negative. Kind of funky. So this would be negative 4 on the outside. All right, we need to think about the exponents, but I don't want to write out 10 x's and 21 y's. That's too many. So I'm thinking I have 10 x's. I need to put them in groups of 3. Antoine already anticipating what I'm going to ask. I need to put them in groups of 3. How many groups can I make? I can make this group. I can make that group. I can make this group. That's 3 groups with a remainder of 1 left over. So I'm going to go ahead and write x to the third power with the remainder of 1x on the inside. I'm going to have x to the third power with a remainder of x on the inside. And then with 21, how many groups of 3 could I make? 7, for sure I can make 7 groups of 3. Y to the 7th power. Are there any left over? No, none left over. So this is my final answer. Y to the 7th. There are none left over. Hi, Melanie. Your schedule change does not go into effect until next week. At the top of it, it says not until Monday. So on Monday, you have class at 9 with me. You're welcome. You should have Miss Pole's class right now. Oh no, you have Miss Pole's class at 1:20. So you have nothing right now, Mel. All right, my friends. Let's look at this one, 4th root real fast. We have 4th root of w to the 4th power, right? I have 4 w's. I need a group of 4. So that w is coming to the outside. Are there any left over? No, there's not, right? So the 4th root and the 4 are kind of like canceling, like we saw in that first section. However, the 4th root also applies to the v here, right? Also applies to the v. How many groups of 4 can I make out of 17? 4 for sure. So I have v to the 4th power here. How many are left over? 1 v is left over. So I have v. I could put to the power of 1, but I don't need to. Right? So this is my answer for this problem. How are we feeling after seeing all? Oh, wow. I definitely didn't take those down. Sorry. If that poll is in the way, my bad. How are we feeling at the end of our notes? for those of you who are still sticking around. Cool. All right, if you are a 2 or 3, don't forget that Miss Yama is gonna have office hours today at 10:30. And then for your assignment today, you're gonna have your notes is here, and then you're choosing 6 in each section. I know 6 feels like there's 18 total problems, feels like a lot, but the first section, this section here should take you no more than like 2 minutes. You can use your calculator if you need to. Your answers are over here. So if you're on the computer, you can actually just drag them into the right boxes if you want. And then section 2, you're practicing a little bit more with square roots and cube roots. And then section 3, a little bit more challenging. So you're gonna pop your work there, and then you have your checkpoint form. Those are the only 2 parts for today. So hoping to get our submission rate through the roof this morning. If you could hold on for one moment before I let you sign off, I'm going to close all of our rooms to talk about our schedule change because you did receive an email earlier today. So I want to let you all know about that. Hi, friends. Welcome back. I want to just update you on one thing before we head out. Wait for everyone to jump back. I have a few people still in breakout rooms. I think everybody should be just about back now. Hi, everyone. Welcome back. I wanted to just let you in on an announcement that you received in your email about 45 minutes ago at 9 o'clock. This class is going to be changing to an afternoon class starting next week. So starting next week, you will not have a morning class. You will have nothing in the morning. And then you'll have Spanish at your normal time, but you will not have a 9 a.m. And then in the afternoon, you will have physics at 1:20. And then you will come to me at 2:05. We'll have a little bit of a break, and then we will, and then we'll start like for our math class. My idea for this is that I will send you the videos in advance like I normally do. I'll have the videos available for you in the morning, so you can actually do the notes in the morning, and then in the afternoon, you can come to me and we can just do the problems together. So starting next week, you will not have a 9 a.m. class. You can just fill out your form from bed and sleep a little bit longer. You're gonna go to Spanish, then you'll go to physics and math back to back. Okay. What time is your math class next week? Chat me so I know that you know. Elvia knows what time it is. Yes, yes, yes. Your math class is at 2:05. So you'll have Spanish, physics at 1:20, math at 2:05. Cool, cool. Okay. I love you. I will see you soon. Bye, y'all. Have a great weekend. Bye. Yay, more sleep. Yeah. Bye. 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 Bye, JR. Amazing, Kim. Thank you. I'll check it this afternoon. Thank you. Thank you.